Hello everyone, it's me Sanjay Vasu back again for another video. This time doing it on Cambridge IGCSE Mathematics Paper 4 Extended Paper for May/June 2022. This is, by the way, the third variant. Just do remember that we need to give non-exact numerical answers to 3 significant figures or 1 decimal place for angles, of course in degrees, unless a different level of accuracy is specified in the question, which means, for example, if in the question it says 2 decimal places, then we give the 2 decimal places. Otherwise, default is 3 significant figures or 1 decimal place for angles. For pi, you can use calculator value or 3.1 for 2. I'm going to use the calculator value. Let's start. Question 1. Here's part of a bus timetable. A. Rashid catches the 0920 bus at Abbott's. Find the time the bus arrives at Southmore. So he catches the 9:20 bus, and that same bus goes to Southmore at 10:07. So that's when the bus arrives there. B. Anissa leaves home at 8:27 a.m. and takes 25 minutes to walk to the bus stop at Calais. She catches the next bus to Center Point. Find the total time in minutes for her journey from leaving home to arriving in Center Point. Okay, so she takes 25 minutes to walk to the bus stop after starting at 8:27. So when will she arrive at the bus stop? 8:27 plus 25, right? So we get 8:52. And now 8:52, when's the next bus at Calais after 8:52? 9:42, right? 9:42. And then that bus goes to Center Point at 10:30. So now that'll be 10:30 minus 8:27, which is the starting time. That'll be equal to 2 hours and 3 minutes, which is 123 minutes. That's the time it takes from start to finish. See, the distance from Abbots to Center Point is 29.4 kilometers. Each bus takes the same time for the journey. Calculate the average speed of a bus for this journey, give your answer in kilometers per hour. So speed is equal to distance by time. That will be equal to 29.4 kilometers by, let's see, Abbots to Center Point is, if you find the time, 1 hour is 10 minutes, which is 70 minutes. That will be equal to, let's get our calculator out. There we go. 29.4 divided by 70, which is equal to 0.42 into 60 for kilometers per hour, 25.2 kilometers per hour. Why do you multiply by 60? Because 1 hour is equal to 60 minutes. We use minutes here, so multiply by 60 to get hours. Let's go to part D. On one journey, all 56 seats on the bus are filled. Ratio of adults to children on this journey is adults to children equals 5:3. The cost for an adult ticket is $2.80. The cost for a child ticket is 3/4 of the adult cost. What are the total cost of the tickets for this journey? First, let's find 280, which means $2.80 into 3 by 4. Divide by 4 there to get $2.10 for children's cost. And then all 56 seats are filled, and adults to children equals 5:3. So that means there will be 8 parts, which is equal to 56 people, right? So that means 1 part equals 7 people. Adults will be equal to 7 into 5 because 5 parts. That would be 35. And the cost will be 35 into 2.80. That will be equal to, let's do 2.8 into 35, which is equal to $98. Now, for the children, that'll be 7 into 3, and multiply that by 2.10, or 2.1 actually. That'll be 7 to 3, 21 into 2.1, which is equal to $44.1. So if we add it up, add $98, that will be equal to, total is equal to $142.10, or $142.10. That's the answer. Let's go to question 2. A. 1. Draw the image of triangle T after reflection in the line y equals x. The line y equals x is this diagonal over here. So minus 5 comma minus 5 goes up 7 comma 7. Why? Because the x and y values are the same at all points. So it's this diagonal. Now, triangle T after a deflection in this line. So first let's deflect each point. What's the shortest distance from this point to the line? That's a diagonal line like that, right? Which is 3 units. 3 diagonal units. On the same line but opposite direction. Like that. 3 units. And that is the reflected point. Over here, it's 2 comma minus 1. So we've done for one point. Let's do for the second point. The shortest distance will be using this diagonal. 1, 2, 3, 4, 5, 6 units. So you do another 6 units. 1, 2, 3, 4, 5, 6. Go over there. 2 comma minus 4. So that's the one. And now for the third point, over here, we go 1, 2, 3, 4, 5, 6, 7 units. And another 1, 2, 3, and then 4, 5, 6, 7. It goes over here, which is 3 comma minus 4. And this is the completed triangle, or the image of the triangle in this case, since it's a reflection image. 2. Draw the image of triangle T after a translation by the vector minus 1 comma 3. So minus 1 comma 3 means 1 left and 3 up. So doing that, we go, let's say this point, 1 left, minus 5 comma 2, 3 up. We go 1, 2, 3. Because 1 unit is actually 2 boxes, that's why we go up 6 boxes. There's 2 boxes, 6 boxes, but there's actually 1 unit and 3 units. So this point comes here, which is minus 5 comma 5 over there. And now the other 2 points, we can plot them according to how they are in the triangle, like that. And now just connect the dots to find the image of triangle T. By the way, this is the one for part 1. There's the one for part 2. That's the answer. Now go to part 3. Describe fully the single transformation that maps triangle T onto triangle A. First of all, we can see the triangle A is larger, which means it's enlargement. So, enlargement. We need to find the scale factor now. Since the triangle has been flipped like that, scale factor will be negative, and flipped like that means rotated 180 degrees. So from triangle T to triangle A, by the way, so that will be a negative value of, let's see the initial, that's, for example, this length, initial is 2, final is 3 for the same length. So it will be 3 by 2, which is 1.5. So scale factor is minus 1.5 because it's been rotated 180 degrees. And then the center will be a 3:2 ratio from each of the corresponding points. So let's say this point to that one. That is a 1, 2, 3, 4, 5 length. So this is 3, this is 2, right? In units of the ratio, at least. So it has to be 3 units away from this point and 2 units away from this point, which is the simplest ratio. So that will be like this, like that. That's how you find it. And it will be that one. Same thing for this. This is 8 and this is 12. So this is a 3:2 ratio, or in this case 2:3 because we're doing with respect to T. And for this one, this is 8:2, this is 12:3. So it is still, there's 3, there's 2, that's 3:2. And then this is 12, this is 8 over here. So that's still 2:3 or 3:2 if you flip it. So the center is this point, which is 0, 3. It's the answer. B. A quadrilateral P is enlarged by a scale factor of 1.2 to give quadrilateral Q. The area of quadrilateral P is 20 centimeters squared. Calculate the area of quadrilateral Q. So since it's area, we multiply this area by 1.2 squared. That will be 20 into 1.44, which is 28.8 centimeters squared. You can calculate it using calculator if you want. You get that answer. Let's go to question 3. A. The table shows the number of tigers reported to be living in the wild in the year 2014 in some countries. The four countries are given along with the tiger numbers. 1. Using the table A, find the number of tigers in Nepal as a percentage of the number in Bangladesh. The number of tigers in Nepal is 198 and that in Bangladesh is 106. So 198 divide by 106 and multiply by 100 to get a percentage. And that'll be, let's get our calculator out, 198 divided by 106 times 100 to get 186.79%. That's our answer. B. Find the ratio tigers in Bangladesh is to tigers in Indonesia is to tigers in India, giving an answer in simplest form. Tigers in Bangladesh is 106, Indonesia is 371, and India is 2226. Now this may not be easy to realize, but this is not in simplest form. The reason is all of these are divisible by 53. And of course, how do I know that? It's because we can say 106 only has two factors other than 1 and the number itself. So they are 2 and 53. 2 times 53 is 106. So dividing by 2 of course doesn't work for all the numbers since this is odd. But dividing by 53 actually works. And since we have a calculator, we can verify that very easily. 106 divided by 53 is 2. Now 371 divided by 53 is 7. 2226 divided by 53 is 42. So the three numbers we have are 2, 7, 42. And that's our ratio. That's our answer. Let's go to part 2. 5 years later, the number of tigers reported in India was 2967. Find the percentage increase of the population of tigers in India. That's going to be 2967 minus the original 2226, which is 2014's population, and dividing by 2226, which is the original. And now we just multiply by 100 to get a percentage. So 2967 minus 2226 divided by 2226 and multiply by 100 to get 33.3%. This is the three significant figures. Now go to part 3. The number of tigers in India in the year 2014 is approximately 30.48% greater than in the year 2010. Find the number of tigers in India in the year 2010. Give your answer correct to the nearest integer. Alright, so 30.48% greater means 130.48% of the original. And that's going to be 1.3048 of the original, right? Because the original is 100%. And 30.48% greater is just adding up. So we get this as a percentage. And as a value or a decimal, it's 1.3048. Now the number of tigers in 2010 is going to be the value in 2014, which is 2226, given by the table. So 2226 divided by the value we found just now, 1.3048. And doing this, 1706 to the nearest integer. (1706), and that's our answer. Now we can go to part B. At the start of June, the hive has a population of 2,000 bees. 3 months after the start of June, the hive has a population of 2662 bees. The population of this hive can be calculated using the formula P equals AB to the power X, where P is the population of the hive X months after the start of June. A and B are constants. By finding the value of A and B, calculate the population of the hive 7 months after the start of June. Give your answer correct to the nearest integer. Alright, we have two pieces of information about the populations. We have 2,000 bees at the start of June, which is basically 0 months after June. Let's first use this. So the population is 2,000, and that's A times B to the power of 0, since it is at the start of June or 0 months have passed. So that means, simplifying, we get A is equal to 2,000. Now we know that A value. So you can write this as P is equal to 2,000 B to the X. Now we have a second piece of information, which is 3 months after the start of June, X is equal to 3. That means the population is 2662 bees. So P is equal to 2662, and that's equal to A, which is 2000 now, multiplied by B to the power of X, or B to the power of 3, since X equals 3. So B cubed is going to be 2662 divided by 2000, which is 1.331. And B is equal to the cube root of 1.331. And doing this on a calculator, 1.331 cube root to get 1.1. And now we know the A and B values. So the population of the hive 7 months after the start of June, P7 I'll write that is going to be 2000 times 1.1 to the power of 7. That's going to be 1.1 to the power of 7 here is that, and multiply by 2000, we get 3897 to the nearest integer, of course, as asked in the question. And that will be our final answer. Now let's go to question 4. A regular 12-sided polygon has side length 6 centimeters. A. Should one interior angle of the polygon is 150 degrees. We can find the exterior angle first. So that's going to be 360 divided by the number of sides, which is 12, 30 degrees. Now the interior angle is going to be 180 minus the exterior angle, which is 180 minus 30, 150 degrees. B. The polygons are enclosed by a circle center O so that each vertex touches the circumference of the circle. 1. Should the radius AO of the circle is 11.6 centimeters to 1 decimal place. Well, we know that this angle is 30 degrees and this is 6 centimeters because that's the side length of the polygon. Now this is the radius AO, and these two angles are going to be equal because OA and OB are both the radii, so triangle formed by two radii and chord will be isosceles. These two are equal. So angle OAB is equal to angle OBA, and that'll be equal to 180 minus 30 divided by 2, which is 75 degrees. So if this angle is 75 degrees over here, we can use the sine rule to find OA. So OA by sine 75 is equal to 6 by sine 30. And 6 by sine 30, which is 6 divided by half if you remember your sine identities. So that's 12. So OA is equal to 12 times sine 75. And that's going to be, using our calculator, 12 times 75 sine, 11.6 centimeters to 1 decimal place. And that's going to be proven. That's our answer. Let's go to part 2. Calculate A, the circumference of the circle. That's simply 2 pi r, which is 2 pi times this 11.5911, which we have on a calculator. So times 2 and times pi. 72.8 centimeters. This is to 3 significant figures, of course. And for part B, the perimeter of the shaded minor segment formed by the chord AB. Well, the shaded minor segment here is a tiny bit of space over there between the sector and the triangle. So to find the perimeter, we have to find the length of AB. The side length is 6, which is the side of the polygon, but we need to find the arc length AB as well. Only then we can find the perimeter. So the arc length of AB is going to be theta by 360 times 2 pi r. And that's going to be, we know that this angle is 30. That's the theta angle, which is the angle at the center from these two chords which make up the arc. And then 2 pi r is the circumference, which we already have. So it's going to be 1 by 12, which is basically 30 by 360, but simplified to 1 by 12, multiplied by 72.82 value, which we have here. So we just divide this by 12 to get our answer, 6.069. But we're not done. We have to add this to the 6 centimeters which we have for the length AB, this length over here, straight line. And when we add this, we get 12.069. And that's 3 decimal places, but you can use 3 significant figures, and 12.1 centimeters is also correct. Now for part C, the regular 12-sided polygon is the cross-section of a prism of length 2 centimeters. Calculate the volume of the prism. Well, to calculate the volume of the prism, we need the area of the 12-sided polygon. So, this area of this polygon here, we can see that is divided into 12 different triangles, like this. 12 triangles, and each one is the same size as OAB, the congruent triangles. So we just find the area of triangle OAB and multiply by 12. So the area of OAB, triangle of course, times 12 is equal to the area of the polygon. And we can find this using half AB sine C, multiplying by 12. And which two sides will we take as A and B? Well, we know that OA is the radius, which is approximately 11.6. Let me just write that there, 11.6 centimeters. And we know this angle as well, OAB, 75 degrees. So we have two sides, 6 and 11.6. And we have an angle, 75. And you can use these. So half times 6 times 11.6 times sine 75 multiplied by 12. Doing this, we get 6 times 11.6 divided by 2 times 12 and times 75 sine to get 403.37 centimeters squared. Now, this is the cross section of a prism of length 2 centimeters. So the volume is going to be equal to this area, 403.37 times 2. And doing that, we get 806.74 centimeters cubed, which is our final answer. You can also write this as 807 because 3 significant figures, but I'm just writing it like this to 2 decimal places. That's also correct. That's our answer. Now let's go to question number 5. The time, T minutes, taken by each of AE people to travel to work are recorded. The table shows the information about these times. A. 1. Write down the class interval containing the median time. The median time will be the time of the 1 plus 80 divided by 2, which is the 40.5, or 40th and 41st people, which are in ascending order, and the time is recorded. So let's find the cumulative frequency to do this. Cumulative frequency, I'll write as CF. So this will be 3. Adding up, we get 10, 28, 56, and then 80 at the end. Remember that the last number for cumulative frequency has to be the same thing as the total number of units. In this case, the total number of people, which is 80. So where is the 40th and 41st time? Of course, it's going to be between 28 and 56, so it'll be in this group. The class interval is 20 less than t less than or equal to 35. Let's go to part 2. Calculate an estimate of the mean time. So to find the mean time, we need to multiply f times x. And in this case, f is going to be the frequency, and x is going to be the midpoint. So x, or the midpoint, for each class interval is 2.5, 7.5, 15, 27.5, and 47.5. And we're not done with just sigma fx. And by the way, the sigma just means the sum of fx. And if you divide this by sigma f, which means the sum of all the frequency, or the highest cumulative frequency, 80. So this is going to be 2.5 times 3 plus 7.5 times 7 plus 15 times 18
plus 27.5 times 56. And lastly, we add 24 times 47.5. And now we divide by the total frequency, which is 80. Now let's do this on a calculator. 2.5 times 3 plus 7.5 times 7 plus 15 times 18 plus 27.5 times 56 plus 24 times 47.5. That's 3010. Dividing by 80, we get 37.625. And of course, this is in minutes. That'll be our answer. Now let's go to part B. 1. One of these 80 people is chosen at random. Find the probability that this person took longer than 10 minutes to travel to work. Give your answer as a fraction in simplest form. So, out of these 80 people, how many take longer than 10 minutes? It's going to be 18 plus 28 plus 24 because these are all have class widths greater than 10. Notice that this is a less than, so this cannot be equal to 10 minutes. So, it all counts. Now 18 plus 28 plus 24, if you do the math correctly, is just 70. So it is 70 out of the total of 80, or in other words, 7 by 8. Why are we writing 7 by 8? It has to be as a fraction in simplest form. If you write 70 by 80 directly there, you'll only get 1 mark, because it's the correct fraction but not in simplest form. You have to write 7 by 8, only then you'll get the mark. Part 2. 2 people are chosen at random from those taking 20 minutes or less to travel to work. Calculate the probability that one of these people took 5 minutes or less and the other took more than 5 minutes. So the people only considered from those taking 20 minutes or less. So those taking 20 minutes or less are just the first 3 columns of the table. So these 3 are only these in consideration. So probability that one took 5 minutes or less, which is 3 out of a total of 28. I'm multiplying this by the probability that the other took more than 5 minutes, which is going to be 25 divided by 27. This is the important part. Why is it 27 and not 28? Well, since they cannot be 2 times of the same person, right? You have to choose 2 different people. 2 different people are chosen at random. So if you choose the first person, that means you have to subtract 1 over here to get 2. Now total is going to be 2 plus 7 plus 18, which is 27 now. And then 25 over 27 is the second probability, or probability of the second one is between 5 and 20. And of course, you have to multiply this number by 2. That's because there are 2 different orders to get the same people. So you could either get this one's first, which is greater than 5 minutes, or you could get this one first, which is less than 5 minutes. So there's 2 different ways that you can get the same 2 people. So you have to multiply by 2. And at the end, it's going to be equal to 150 divided by 756. And we can simplify this by dividing by 6 on both sides. This will become 25 divided by 126. And that's our final answer. Now let's go to part C. 1. Use the frequency table on page 8 to complete the cumulative frequency table. Well, we've already done this, right? We can see 3, 10, 28, 56, 80, and we just write this in 28 and 56. Part 2. On the grid, draw a cumulative frequency diagram to show the information. So we can label at t greater than or equal to 5, cumulative frequency is 3. So it'll be around here. Now, t less than or equal to 10, cumulative frequency is 10. T less than or equal to 20, it's going to be 28. 35 minutes or less is 56, which is up here. And 60 minutes or less is going to be at the 80 mark. And drawing the graph, we get something like this. That's our answer. Let's go to part 3. Find an estimate for the 80th percentile. So the 80th percentile is going to be 80 by 100 times whatever frequency you have, 80, which is at the 64th value. And the 64th value is going to be, drawing a straight line to that, 40 minutes. That's our answer. Now for part 4. Estimate the percentage of people who took longer than 45 minutes to travel to work. Show while you're working. So the number of people who took longer than 45 minutes is approximately 80 minus 70, because 70 is those who took less than 45 minutes. Now greater than 45, as I said, is approximately 10 people. Now if this is 10 people, then the percentage, which is greater than 45 minutes, is going to be 10 divided by a total 80 times 100% to make it into a percentage. That's going to be 12.5%. So that's our answer. Let's go to question 6. A. Simplify a minus 2b minus 3a plus 7b. So first we can group the like terms. A minus 3a plus 7b minus 2b. That's going to be minus 2a plus 5b. You can write it as 5b minus 2a. It's still correct. That's our answer. Let's go to part B. Expand and simplify 4 times x minus 5 minus 3 minus 2x. So that's going to be 4x minus 20, expanding the first bracket, and then minus 3 plus 2x, expanding the second bracket. Remember that this minus is basically a minus 1. So minus 1 times this, expanding it, we multiply these two, and we multiply these two. So minus 1 times minus 2x is going to be a positive 2x. That's why we got that. Now we can simplify this to get 6x minus 23. That's our answer. Let's go to part C. Write as a single fraction in simplest form. 3 by x minus 5 minus 7 by 2x. So we can cross multiply to get 3 times 2x minus 7 times x minus 5 divided by x minus 5 times 2x. And that's going to be 6x minus 7x plus 35 by the denominator here, 2x times x minus 5, which is simplifying minus x plus 35 by 2x times x minus 5. So that'll be our answer, 35 minus x by 2x times x minus 5. Now let's go to part D. Solve. 13 minus 4x by 3 equals 6 minus x. First, you can multiply by 3 on both sides. So 13 minus 4x equals 3 times 6 minus x. And this is simply 18 minus 3x. Now we can bring 4x to the side. So x plus 18 is equal to 13. And x is equal to 13 minus 18, or minus 5. That's our answer. Let's go to part E. Make x the subject of the formula. 5 times p minus 2x divided by x is equal to y. So first we can expand the bracket. Y is equal to 5p minus 10x by x. Now we can split the fraction into 2, like this. So 5p by x minus 10x by x, or is just minus 10. So y plus 10 is going to be equal to 5p by x, right? And x times y plus 10 is 5p, y being x here. And x is going to be 5p divided by y plus 10, which is our final answer, 5p by y plus 10. Let's go to question number 7. Question 7. The diagram shows a field ABC. A. Calculate the length BC. We know two sides, and we know the angle enclosed by that side. And we know the angle enclosed by these two sides. So we can find the third side using the cosine rule. Because it's opposite the angle A, we can label it as side A. This is side C, this is side B. So A squared equals B squared plus C squared minus 2BC cosine A. And therefore, we can say that BC squared is 55 squared plus 82 squared minus 2 times 55 times 82 times the cosine of 76. So that's going to be equal to, getting our calculator out, here we go, 55 squared
plus 82 squared, that's 6724, and we subtract 2 times 55 times 82 times the cosine of 76 to get 7566.864. Now if we square root this, we'll get BC. So square rooting, we get 86.98, or just 87.0 meters, to three significant figures. Now let's go to part B. Calculate angle ACB. So we know the side C, which is 82 meters. We also know the side A, which is 87 from our previous question, and the angle A, 76 degrees. Just a side note, the side A is always opposite to angle A, and same for the other two sides and angles. So we want the angle ACB, which is the angle C, and that means A by sine A is equal to C by sine C using sine rule. And we can just substitute all the values that we know. 87 divided by sine of 76 is equal to 82 divided by sine of this angle which we want, ACB. So that means the sine of angle ACB is going to be equal to 82 times the sine of 76 divided by 87. This is because we bring this denominator to the other side, that becomes multiplication instead of division. And then this full fraction, we bring it to the other side, we have to flip the fraction. So it's 82 divided by 87 by sine 76, and we flip the fraction to get 82 times sine 76 divided by 87. And now we can find the angle ACB, which is going to be the sine inverse of all this, which we've written. 82 times sine 76 by 87. And this is going to be equal to, using our calculator, 82 times sine 76 divided by 87. And of course, sine inverse, 66.1 degrees. That's our answer. Now, let's go to part C. A gate G lies on AB at the shortest distance from C. Calculate AG. Well, the shortest distance from C on the line AB will be the perpendicular distance. So the point G lies on this line perpendicular to AB if you draw the line GC. In other words, let's say there's point G, this is a right angle here. Well, we know that if the angle between the side and this line, which extends from the side to another point, the third point on the triangle, and this is 90 degrees, then this is the vertical height of the triangle, and in that case, this could be the base, right? If there's the base, there's the vertical height. So we know there's a formula for the area of a triangle which involves those two, which is half times base times height. There's also another formula which we can use, which is half AB sine C for the area of a triangle. And we can find that using these two sides and this angle. So we can find this length GC. And using that information of GC, because this is a right angle triangle, we can find the length AG. So first, half AB sine C, and in this case it's going to be 55 times 82 times sine 76. It's going to be equal to half times the base, in this case 82, times the height, which is CG. Now CG is going to be half times this 55 times 82 times sine 76, dividing by half times 82, because you bring these to the other side. Now we cancel out this, and 55 times sine 76 is, using our calculator here, 53.366. And of course this is in meters. Now AG,
we need to find. And we have a right angle triangle here with G over here, and this angle we know is 76. We know that CG is 53, and therefore we can find AG using the tan formula. We know that this is the angle which we're using, so this is the opposite, which is CG, and AG is the adjacent. So opposite by adjacent is tan of this angle, right? Tan 76. And therefore, to find the adjacent, it's the opposite, which is CG, divided by tan of 76. So AG is going to be this 53.366 divided by 1076, and doing that we get 13.3 meters. That's the three significant figures. So answer. Now let's go to part D. A different triangular field PQR has the same area as ABC. PQ equals 90 meters and QR equals 60 meters. Work out the two possible values of angle PQR. So if they have the same areas, that means either half BH is equal or half AB sine C is equal. So since we have two sides, we can find the angle between them, which is PQR. So if this is PQ and R, the angle between PQ and QR is angle PQR, which we need to find. So we can compare the areas. So the area of the triangle we have already is half AB sine C, right? Using half times A2 times 55 times the sine of 76. And that's going to be equal to half times 90 times 60 times the sine of the angle PQR. So sine of angle PQR is going to be equal to this whole thing divided by this. So let's just do that on a calculator quickly. Half times 82 is 41, and then times 55, and then times the sine of 76 to get this. Now dividing by 45, since this over here, half times 90 is 45, and now we divide by 60 as well to get 0.8103 approximately. So 0.8103 ... and angle PQR has two different values, as you can see. So two possible values of angle PQR, it's not just one, because a sine graph looks like this, right? So this is 0, this is 180, and this is 360. And if sine of angle PQR is 0.8103 ... it'll fall on this line here. And there's two different intersection points. So there's two different values. And how you relate the two values. The first one is just going to be the calculator value, which we'll call alpha. So let's just write sine PQR equals alpha, the calculator value. And the angle PQR can be alpha or 180 minus alpha, since this is positive. If this was like some negative 0.8103 ... then of course it would change. Then it would be either the calculator value or 540 minus alpha. So over here we can just do the sine inverse, which is 54.132, or we'll do 180 minus 54.132, which is 125.868. So to one decimal place, we'll get 54.1 or 125.9, and that'll be our answer. Now I can go to question 8. Question 8, A. A has coordinates minus 2, 7, and B has coordinates of 1, minus 5, and C has coordinates of 5, 4. 1. Find the coordinates of the midpoint of the line AB. So the midpoint is going to be x1 plus x2 by 2, which is the sum of the coordinates of the x values divided by 2. and then y1 plus y2 by 2. That is the y-coordinate, which is the sum of the other two y-coordinates divided by 2. That gives the midpoint. So we get minus 2 plus 1 by 2, which is minus half, comma, 7 plus minus 5 by 2, which is 1. So minus half, comma, 1 is our answer. Now, going to part 2. Find the vector AC. Vector AC is going to be equal to the point C coordinates minus the point A coordinates, and we just write that in vertical notation. So 5 comma 4 minus 2 comma 7, and this will become 7 comma minus 3, and now we just write this in vertical notation to get 7 minus 3. Part 3, find the magnitude of AC, or mod AC. So the magnitude is going to be equal to the square root of x squared plus y squared. That's now going to be equal to the square root of 7 squared plus minus 3 squared. That's the square root of 58, and doing that on our calculator, we get 7.62 to 3 significant figures. Part 4. Find the equation of the line AB. Give the answer in the form y equals mx plus c. First, we can find the gradient, m, y2 minus y1 by x2 minus x1, which is minus 5 minus 7 by 1 minus 2, which is equal to minus 4. Now, as for y equals mx plus c, we can substitute y equals minus 5, m equals minus 4, and x equals 1, and plus c, which we don't know. I'm using the coordinates of b since it's easier, but you can use the coordinates of a as well. It's fine. So c is going to be equal to minus 5 plus 4, which is equal to minus 1. So y is equal to minus 4x minus 1, and that'll be our answer. Now I can go to part 5. Find the equation of the line perpendicular to AB that passes through the point C. Give your answer in the form y equals mx plus c. First of all, this gradient, the new gradient, let's just name it m0, that's going to be minus 1 divided by the gradient of AB. So that's going to be minus 1 divided by minus 4, which is 1 by 4. Now, this line perpendicular to AB passes through the point C, which has coordinates 5, 4. So y is equal to mx plus c, y is 4, x is 5, and m is 1 by 4. And then plus c. So c is equal to 4 minus 5 by 4, which is simply 11 by 4. And that means we can write the equation is y equals 1 by 4x plus 11 by 4. That's our answer. Let's go to part B. The graphs of y plus 5x equals 8 and y equals 2x squared plus 6x minus 13 intersected the points P and Q. Find the coordinates of P and Q. Show all your working. Well, first we can write this as equation 1 and this as equation 2. Now you can rearrange equation 1 to make it y equals 8 minus 5x. And we can substitute this into equation 2. So since we have a y here, we can just write this as 8 minus 5x. That's equal to 2x squared plus 6x minus 13. Now this means 2x squared plus 11x minus 21 is just 0. And of course that is by bringing both of these to the other side. Minus 5x becomes plus 5x and 8 becomes minus 8. So if we factorize this correctly, we'll get 2x minus 3 times x plus 7. And of course that's equal to 0. So that means x has to be equal to a value where either this is equal to 0 or this is equal to 0. So if 2x minus 3 is equal to 0, then x is 3 by 2. Or if x plus 7 is 0, then x equals minus 7. Now we know the x values. So let's just say the x coordinate of P is 3 by 2 and the x coordinate of Q is minus 7. You can do it the other way around as well, but this is just one option. Now we can find the y values. I'm going to substitute it into this equation, which is the same thing as equation 1. You can substitute into this, but it takes a bit more time. That's why you do it the first one. So y of p is equal to 8 minus 5 times 3 by 2. And that's going to be half. And now the y coordinate of q is going to be 8 minus 5 times minus 7. That's going to be 43. So point P is going to be 3 by 2 comma half, and point Q is going to be minus 7 comma 43. You can write it as this is point P and this is point Q. It's still correct. Well, that's going to be our answer. Now going to question 9. A. Sketch the graph of y equals x plus 1 times 3 minus x times 3 plus x, indicating the coordinates of the points where the graph crosses the x-axis and the y-axis. Well, since this graph has already been factorized and it's a cubic graph, first of all, we need to find out if y is equal to ax cubed plus bx squared plus cx plus d. We need to find if this is going to be positive or negative. So we can write 3 minus x as negative of x minus 3. So this whole equation will be minus of x plus 1 times x minus 3 times x plus 3, because 3 plus x is the same as x plus 3. And if we simplify this, this first term will be negative when you multiply all this, since there's a negative in front. So minus x cubed, and there'll be more stuff after that. So this graph will have a shape like this. It'll come from above, and then it'll have a turning point minimum, and then it'll have a maximum, and then go down again. Now, what are the x-intercepts? That means y is equal to 0. So the x-intercepts, that's going to be x is equal to minus 1, x is equal to 3, and minus 3. Because each of these brackets has to be equal to 0. So if this is 0, it's minus 1. If this is 0, it's 3. If this is 0, it's minus 3. So we can just label 3 different points on the x-axis like this. So this is minus 3, this is minus 1, and this is 3. Now what about the y-intercept? That means x equals 0. So we just substitute x equals 0. 1 times 3 times 3, which is equal to 9. And now we actually do not really need any more information to draw the graph. So the y-coordinate will be 9, which I'll just label over here. Remember that these two do not have to have the same scale. The axes can have different scales. So even if this is minus 3 and it looks like this distance is larger than the distance to 9 over here, it's still fine. So drawing the graph, we get something like this. And this will be y equals x plus 1 times 3 minus x times 3 plus x. The only points that we have to indicate are the points where it crosses the x and y axis, and we labeled it. So it's fine, and that'll be our answer. Now going to part B. 1. Show that y equals x plus 1 times 3 minus x times 3 plus x can be written as y equals 9 plus 9x minus x squared minus x cubed. Well, this is a simplification question. So we can just say that y is equal to finding 3 minus x times 3 plus x. That's just x plus 1 times the difference of squares, right? So this is in the form of a minus b times a plus b, and therefore we can write this as a squared minus b squared. And in this case, a is 3, so 3 squared is 9, minus b squared, which is x squared. And that means y can be written as 9x plus 9 multiplying the inside, and we multiply what's outside minus x cubed, and we multiply the last, so minus x squared. And rearranging this, y equals 9 plus 9x minus x squared minus x cubed, and this is what's given in the question, so it's proven correctly. That'll be our answer. Now going to part 2. Calculate the x values of the turning points of y equals 9 plus 9x minus x squared minus x cubed. Show all your working and give your answers to 2 decimal places. So to find the turning point, first we need to find dy by dx and set it equal to 0, since at the turning points the gradient is equal to 0. So dy by dx is equal to 9 minus 2x minus 3x squared. So that means 3x squared plus 2x minus 9 is also equal to 0, since we can just negate this, and negating 0 is still 0, so it's still the same. Now we can use the quadratic formula. We can see that the question says give your answers to two decimal places, so there's likely no good factorization of this equation. So therefore, we can just say that we have to solve it using the quadratic formula. So x equals minus b plus or minus root of b squared minus 4ac by 2a. And in this case, we can replace everything. So minus b will be minus 2 plus or minus 2 squared minus 4 times 3 times minus 9 divided by 2 times 3. And that's going to be equal to get our calculator out. So first it's minus 2 plus or minus root of 112 divided by 6. And now we can find the square root of 112. For the positive answer, subtract 2 divided by 6 to get 1.43, two decimal places. And one more value, which is subtracting root 112. So minus 2 minus the square root of 112. That's minus 12.58 dot dot dot. So dividing by 6 is just minus 2.10, two decimal places, of course. So these two will be our answers. They have just asked for the x coordinates, which is why we're leaving it like this. Part 3. The equation 9 plus 9x minus x squared minus x cubed equals k has one solution only when k is less than a and when k is greater than b, where a and b are integers. Find the maximum value of a and the minimum value of b. First, let's get an intuition of what this question asks. So we want to know the range of values of y, or in this case, y is equal to k, right? So we want to know the range of values of k, where this equation has only one solution. So that means if we draw this line y equals k, then we have this equation, which is already drawn on this sketch. So drawing the line y equals k, it is a horizontal line. It has to intersect at only one point with this graph. So it can either be below somewhere here or somewhere around here at the top part of the graph. So which range of values does this k satisfy? To find where it intersects one and only one point on the graph, we have to find where it intersects 2 points, because that is the values of a and b which we want, right? Because this is strictly less than and strictly greater than. So if the k value is less than a, or it is less than this value where it intersects at 2 points, then it'll have only one solution. So all these coordinates which I have dashed, if you draw a horizontal line through them, the horizontal line only intersects the graph at this coordinate. It won't intersect anywhere else around here. But if you draw a horizontal line above this value of k or y, that means it'll intersect at 3 points. It won't intersect at 1. So of course, our a value will be the y coordinate of the turning point over here. So this is x is equal to minus 2.10, right? Because it's on the left of the y-axis, so it's negative. So the y value for this is going to be, using our calculator, 9 minus 9 times 2.1 minus 2.1 squared plus 2.1 cubed. Why are we making it plus? First of all, yes, it's minus 5.049, but then why are we making this minus over here as a plus? Because the cube of a negative number is a negative number itself. Another negative over here will cancel out with the negative inside this x cubed, or in other words, minus 2.10 cubed. Therefore, we have to add, not subtract. And that's why we get this. And now we have one more point, right? We have a b value which you need to find. And that b value will be the y coordinate over here. So this is x is equal to 1.43. And y will actually be equal to 16.9 if we computed it. And this will be our expected b value. But we're not done yet. So you found that x will be, a will be minus 5.049 and b will be 16.9. But these are wrong because these are not integers. In the question, it's asked that a and b are integers. This is why they have asked for the maximum value of a and the minimum value of b. Well, how do we make these values integers? Since you want the maximum value of a, but then when k is less than a, this has to have one solution. So this value of a is going to be the maximum value. So the largest integer, which is less than this value, is going to be minus 6. And now for b, when k is greater than b, this equation has one solution only. Well, so since this is the minimum value of b needed, we need the minimum value of b which is greater than the one which we found. So we will get 17. And of course, these two are integers and these will be our answer. Let's go to question 10. The diagram shows a cuboid A, B, C, D, E, F, G, H. CG is equal to 6 centimeters, which is the height. AG is 24 centimeters, the long diagonal. And AB is equal to 2 times BC. A. Calculate AB. So we know that AB is 2 times BC. So first of all, we can find the length of AC. And then using that, we can find AB and BC because double Pythagoras theorem. Usually, the questions give the value of AB, the value of BC, and the value of CG, and they ask you to find the length of the long diagonal. But in this case, they have given it the other way around. So you basically have to do everything which you do normally for such a question to find the long diagonal length, but you do it in reverse order. So first you find this length using long diagonal and the height, and then you find these two because they're related to each other. This is 2BC, so we can find the answer. So firstly, we can find AC. AC squared plus CG squared is equal to AG squared, since this forms a right angled triangle. Now that means AC is equal to the square root of AG squared minus CG squared, which is going to be square root of 24 squared minus 6 squared. And we can leave it as square root of 576 minus 36, so square root of 540. I'll tell you why we do not need to use a calculator and find the value. So basically, AC squared is also going to be equal to 2BC squared plus BC squared, right? And now AC squared will become root 540 whole squared. So that'll cleanly become 540. That's equal to 5 times BC squared, right? Because this will become 4BC squared and we have BC squared, so adding them we get 5BC squared. And that means BC is equal to the square root of 540 by 5, and that's going to be equal to, using our calculator, 540 divided by 5, we get 108. Square root is 10.39. And now AB is going to be 2BC, which is multiplying this value by 2, 20.8 centimeters to 3 significant figures. Now we can go to part B. Calculate the angle between AG and the base ABCD. So that'll be the angle between AG and AC, or in other words, angle GAC. So we know that this is 24 and this is 6. So using trigonometry, or in other words, the sine function of trigonometry, we can say that sine of angle GAC is equal to the opposite by hypotenuse. And in this case, the opposite to this angle is 6 centimeters and the hypotenuse is 24 centimeters. So 6 by 24, which is 1 by 4. Now the angle GAC is going to be the sine inverse of 1 by 4. And using our calculator, we will get 1 divided by 4 and then sine inverse to get 4.5, 14.5. So that'll be our answer, 14.5 degrees. And with that, I come to the end of the video. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.